In this video, we're going to talk about the Morpho language. You'll learn the main elements of the language, including variables, expressions, and statements, some common data types, control flow, functions, classes, and objects, and also about how to extend Morpho. Every time that you see the triple asterisk on the slides in the corner, this indicates an advanced topic, and if you don't quite understand it, you can feel free to skip the content. One thing that's really key about Morpho is that it has a very compact syntax. Almost everything in the language fits on a postcard, which hopefully makes it easy to learn. To write a Morpho program, it consists of a sequence of statements that the Morpho environment will execute in order. In this sequence, we create a variable called a and store the number 5 in it. In the second statement, we add 5 to the variable, and then finally we print the contents of the variable. Each of these is a separate statement. Like other C languages, you optionally can end a statement with a semicolon, but it's generally not necessary. It's important to comment your code to explain what you're doing, and you have two options to do this. Anything that follows the double slashes is a single line comment, that's like C++, or anything surrounded by slash asterisk followed by asterisk slash is a multi-line comment, that's more like C. However, unlike C, these comments can be nested. If you have a sequence of statements, they can be combined into a code block, which are delimited by the curly braces, as you can see. A very powerful thing is that variables created within a code block only exist in the code block. And so here we have a code block that contains what's called a local or private variable called a, which we assign something to. After it's defined, we're able to print it. But then after the end of the code block, the variable a no longer exists. And so the second statement is actually going to raise an error because that variable is no longer visible. So now we've learned a little bit about variables, we'll now look at some common data types that Morpho supports. You can create a variable, and variables can hold any type. Among those are really basic things like integers, floating points, complex numbers that are written as shown. You can also create strings, lists, matrices, and many more. We'll have a little bit more, we'll look at a few other options. A very common category of type are collection types. Here are some examples. So lists are one-dimensional. We can add things to the list. We can change the contents after we've made it. Tuples are also a one-dimensional ordered collection, but can't be changed after they've been created. Arrays are multi-dimensional and can be changed arbitrarily, but the size is fixed when we define the array. Another category of collection is called a dictionary, or sometimes called a hash table. This is a map from keys to values and provides efficient lookup for the contents. The final kind, which is really useful when writing loops, are ranges that are sequences of numbers from start to finish with an optional increment. Here we're going from 0 to 10 in steps of 2. With the triple dot notation, that means we're not including the upper bound. Anything that evaluates to something like a number or a string is called an expression. And so here we have a sequence of code that converts Cartesian coordinates to polar coordinates. Arctan xy is an expression that evaluates to a number, and we store it in theta. We then calculate the radius by taking the square roots of x squared plus y squared. And then, having calculated those two quantities, we'll print them using something called string interpolation that allows us to insert the quantity into a string which makes output a lot simpler. All of the quantities that are underlined are examples of expressions because they're all things that can be evaluated to produce something like a number or a string. We'll now talk about control flow. Morpho supports several control flow things. So the first kind are if and else. This allows you to conditionally execute code. And you can build a structured sequence like as shown. The first condition is checked if b is bigger than 0, and that prints a plus sign. If that's not true, then the second condition is checked after the else. This then checks if b is less than 0, and if so, it prints a minus sign. And if neither of the first two conditions are true, then we jump to the third statement, which just has an else, and and 0 gets printed if neither b is bigger than 0, b is less than 0 was applicable. Morpho supports a number of ways to repeat code. The most common is a for in loop. The first example counts from 1 to 5. 1 to 5 you'll see has the double dots. It's a kind of range. It's an inclusive range, so all of the numbers between 1 and 5 are included. And for each value in turn, I will take on that value, and hence the code inside the block will be printed. The value of I will be printed. The second example loops over the contents of a collection, and for every element, A takes on the value of the element, but the new variable k will actually give us the numerical index, which is occasionally useful. There are two other loop types, while and do while, available. While is really useful if you're modifying the contents of an object as you're looping over it. So a very common use case is to make something called a stack using a list. So here's our list, 1, 2, 3. Then the loop checks to see if there's anything left in the list. If so, it pops the last item off and prints it, and hence the loop continues until there are no remaining objects. A do-while loop is probably the least common sort, but is really useful if you want to run the contents of the loop at least once. And here's just a short example. Another kind of structured statement is a try-catch statement. Use this if you expect the code to potentially generate an error. Here we're opening a file for reading, but the file may not exist. And so if the file doesn't exist, this will raise a file open failed error. If that happens, control transfers to the relevant statement in the catch blocks, and we can add code to handle that eventuality. For example, it may be that the file is optional, and if it doesn't exist, we don't actually mind, we'll just continue. The next topic is functions. Morpho contains a variety of built-in functions like the square root function, but you can make your own using the fn keyword. You have to give the function a name, a set of parameters, and then a code block containing the definition of the function. Anything that follows a return statement, and you can have as many as you like in the function, will be returned as the outcome. The first function computes the norm of a 2D Cartesian pair of coordinates. The second doubles the input value. You can also define your function to include optional parameters. Here we have a function that has what is called a positional parameter x and an optional parameter a. You always have to give it a value of x when you call it, but you can pass a value of a only if you want to. If you don't specify the value of a, it will take on the default value from the function definition. So here are two examples of calling the function. We can call it just with one parameter, or we can supply it with the optional parameter a now defined. Another valuable feature is that when we define functions, we can restrict the allowed types of parameters that it accepts. So here are some examples. We can define a function f that accepts a single list argument, and then when that executes, it's guaranteed to contain a list. We can define multiple versions of the function that accept different types. We could even define multiple versions of f that accept different numbers of parameters if we so wish. When we execute code that calls f, the correct implementation, in this case the list, is selected at runtime. A very helpful feature is that functions are data in Morpho, they're objects themselves, and we can pass them around like other variables. So this function here takes a parameter g and then calls g with the second argument x and returns the value. So if we call f with sine and pi over 2, that will compute the sine of pi over 2. We could also assign functions to variables and manipulate them like any other object. A rather advanced topic, but a helpful one, is that functions can actually enclose variables that are passed to them. So here we have a function f that manufactures a function that gives a specific amount to its parameter. So f makes a new function g that will add a, which is defined whenever f is called, to the contents of its parameter. Hence, if we call f with the parameter 2, what that does is it makes a function that will add 2 to whatever it's called. Then we call p, the new function, with the value 10. What we'll get is 12 because that's 10 plus 2. Now for classes and objects. Morpho is a deeply object-oriented language. Most quantities actually are objects. They're packages of information, data, and a collection of methods or things you can do with them. Most Morpho code involves creating objects. You can usually identify when an object is made because the function starts with a capital letter. Once you've made objects, you can tell them what to do by calling a method on them and giving some parameters. You can also specify and manipulate an object's properties as well. You can make your own object types with the class keyword. Here we're making a class called pet that when we make a pet, it takes a name and stores it. The special method in it is called the initializer. It is what allows us to specify the initial state of the object. We now make a second class called dog. Dog is an instance of pet or a subclass of pet. So it inherits the same initializer from pet, but then adds a second method called bark. And what bark does is it takes the name that we gave it when we created it and prints a simple message. Like so. Here we'll create a dog called Fido and then tell Fido to bark. We're able to inherit from more than one parent. So here we make a cat, which is using the pet class as its parent, but because cats can climb, unlike dogs, I guess, we'll also inherit from this new class climber. As well as the inherited methods, the cat class will define another method to hiss. We're able, just like functions, to create methods that accept different types as their arguments. And again, just like functions, the correct method will be selected at runtime. The final topic is how we can extend the Morpho environment. And the key idea here is that Morpho provides a variety of modules or libraries that you can use with the import keyword. So we can import a module like plot, which is available to Morpho. We can also use any file we like that is in the same directory or a subdirectory of the file that we're running, and we can import it with the quote marks. We can control which symbols are imported from a library using the for keyword. So here we're importing the color library with red, green, and blue. And the key idea is that only these symbols will be imported. Everything else in the library is ignored. Modules can actually be written in Morpho itself, or in fact it can be written in any compiled language such as C. Another powerful feature is that we can import the contents of a module into something called a namespace. This allows us to control how the identifiers in the library appear. So here we're importing color as a special into a namespace called col, and then every time we want to use something from the color library, we'll use col to identify it. So we can make a new color, here lilac, using col as the namespace identifier, and then color as a function that's defined in the library. If we want to make a function that accepts the color as an input, we again have to use the namespace definition. This is a really useful feature because it allows us to separate libraries that might have different implementations of similarly named things. So you're now ready to create your own programs in Morpho, having learned about all the basic features of the language, and we encourage you to try it yourself. Morpho is a small, open source, and easy to learn language for computational differential geometry and more. You can get it at the GitHub, and we'd love to hear your experience. Thank you for listening.